In this video, I will be looking at a couple of example problems from 2.4. Remember, when we're working our word problems, first we'll get to the question sentence. On this particular problem, it says, what is the total cost of the fences? We're interested in finding the total cost of the fences. Alright, a garden is in the shape of a square with a perimeter of 36. The garden is surrounded by two fences. One fence is around the perimeter, where the second fence is 2 feet from the first fence on the outside. Alright, so let's see if we can draw this picture. We have one garden, or one square, that has a perimeter of 36 feet. Okay. So if the perimeter is 36 feet and it's a square, we know each one of these sides is 36 divided by 4, or 9. Each side must be 9 feet in length. Alright. We have a second fence that is 2 feet from that first one. Okay, I'm going to erase my 9 right here so it doesn't get in the way of my drawing here. But now I'm going to extend out a little bit, 2 feet, in all directions. 2 feet here, 2 feet here, 2 feet here, and draw myself a new fence. I'm going to erase my 9s. We know my inside fence is 9. Okay. So now I'm drawing an outside fence. Alright. And if this red length is 9 and we've added 2 on each side, 2 and 2 is 4. And 9 more is 13. This distance is 13. This distance in here is 9. This distance is 13. Well, the perimeter of my outside garden, or my outside fence, is 13 times 4 because it's a square as well, even though my picture doesn't look like a square. And 13 times 4 is 52. So our total fence will be 36 plus 52. And that is 88. And then it says the material is $1.45 per foot, so we'll simply multiply 88 times 1.45, and whatever that yields, this number will be the answer to this problem. That is example number 1. Now on to example number 2. Okay, first I get to the question sentence. This is example number 2. It says, find the base and the height. Sounds like we're talking about a triangle. It says the base of a triangle is, well, this is extra information here. I've just copied it twice accidentally. Pardon me. The base of a triangle is 9 inches more than 3 times the height. If the area is 15 square inches, find the base and the height. Well, again, begin by drawing yourself a picture. It doesn't say that it's a right triangle, but I'm drawing a right triangle here. The base of a triangle is 9 inches more than 3 times the height. Alright, it doesn't matter which one of these we call the base and the height. Base and height are defined because they are perpendicular to each one. So I can call this one the base and I can call this one the height. It doesn't matter. I want to find what the measurement they're basically beginning with. Which one are they working off of? Well, it's the height. It says the base is 9 more than 3 times the height. So they're taking the height and manipulating it to get to be the base. So I'm going to define my variable. H is going to be my height. Okay. H is going to be my height. And I'm going to call this one the height only because I could have called this one the height. It doesn't matter. I'm calling this one the height because it looks like the base is more than the height. And so in my picture, this one looks more. It totally does not matter which one you call the base and the height in this circumstance. Alright, but it says the base is 9 more than 3 times the height. So if the height is h, the base is 9 more than 3 times that. This length here is going to be 3h plus 9. Alright, let's look and see if we have it like we want it. The base is 9 more than 3 times the height. 9 more than 3h. And the height would just labeled h. Alright, it says the area of the triangle is 15 square inches. You might have a problem on yours that deals with a rectangle, but it'll be the same principle. Area for a triangle is 1/2 base times height. If you're dealing with a rectangle, area of a rectangle, it is simply base times height, or length times width. These two terms are analogous. Alright, so I'm not using this one. I am using this one. Now I'm simply going to substitute base and height into this. The area we know to be 15, so the area of my, coming down here, the area of my triangle is 15 equals 1/2. Now I simply need to substitute these two quantities in. Well, height is staying as height. My base is this, 3h plus 9. Alright, now I'm ready to, I can multiply this 1/2 through here, but what I'm going to do is multiply both sides by 2. If I multiply both sides by 2, 15 becomes 30. And 1/2 becomes 1, that goes away. So I have h times these two. H times 3h is a 3h squared. H times 9 is a 9h. Alright, now I have a quadratic. When we have a quadratic equation, one way to solve it is to set it equal to 0 and factor. So I'm going to subtract 30 on both sides. Subtracting 30. When I do, I have 0 over here. I have 3h squared plus 9h minus 30. Hopefully you notice the greatest common factor on this side is 3. Factoring out of 3, I'm left with h squared plus 3h minus 10. Alright, now I have my trinomial in here. I'm coming over with my big X method. In the bottom is a times c. 1 times negative 10 is negative 10. In the top is 3, plus 3 that is here. Okay. So I want to pick numbers that multiply to give negative 10 but add to give 3. Well, 10 is either 10 times 1 or 5 times 2. It's a negative, so 1 will be plus, 1 will be minus. So really I'm thinking subtract to give 3. That's 5 and 2. It's a positive 3, so it'll be positive 5 and minus 2. So we have 0 equals 3, 2 parentheses. We know we need our h, and we're going to have plus 5 and minus 2. Now, we have these three factors equaling 0. Well, the 3 doesn't matter. We know that 3 cannot equal 0, so we don't even have to worry about that. We're looking at these two factors equal 0. I'll set both of them equal to 0. H plus 5 equals 0, and separately, H minus 2 equals 0. Here, subtracting 5 on both sides, I get that H is negative 5. Here, adding 2 on both sides, I get that h is 2. So we're seeing h can be 2 and negative 5. Well, back to our drawing, h is a length, so it can't possibly be negative. So in this context, h equal negative 5 will not be applicable. While it does solve this equation, it is not appropriate contextually. So now I'm going to try h being 2. If h here is 2, then substituting 2 here, 3 times 2 is 6, plus 9 is 15. Will 2 and 15 work? Well, substituting in here, yes it will. 2 times 15 is 30, and half of that is 15. So we have just found the base and the height. Height is 2. in our base is 15. And that concludes these examples.